Swayam Prabha. Digital India. Educated India.
So welcome back. See, this particular presentation is to make uh, whatever you have learned in the morning to make it more Indian context. First, I will be talking about some introduction where I will be saying about the brief history of our country, the pioneers who brought in the technology. See, prestressed concrete is also another technology like precast concrete. And both of them have overlap. And that's why pre-stressing of precast members is quite common. The professional organization in United States, PCI, the full form is Precast Prestressed Concrete Institute. That means you can understand that they have combined both these technologies under one umbrella. After the introduction, I will be talking about the advantages. Again, these are not like something to just memorize and spill over in a quiz. No. You have to keep this in mind while taking decisions. So I know the practicing engineers, they are to take the decision whether you go for a certain technology or not. Now, for that, you need to know at least the pros and cons from the technical side. But apart from this, there's also the construction, the economics, those things also come in the practice. Environmental issues. Next, I will be talking about the process and the devices of the pre-tension members, which I have restricted only to precast. And I've given some photographs to understand. And the next is the post-tension members. Losses in pre-stress, very brief. I'm not going into any codal provision. This course is not, or I would say this lecture is not meant to cover up pre-stress concrete. No. This is just to give you a flavor to connect it with this short-term course. And hence, I'm covering only the analysis which is based on mechanics, no design. Professor Liberoth has already covered the design, and it is nice that you got exposed to the way it is handled under the Eurocode. I'm not going to cover the design, but I will give you the reference in case if you haven't done a course on prestressed concrete, you can go to that reference. Myself and my senior colleague, Professor Devdas Menon, we had developed a web-based course on prestressed concrete structures under the program of National Program on Technology Enhanced Learning. If you are interested, you can go to this and learn more about the prestressed concrete. Actually, I have picked up the slides from there only, but I made it a summarized, like a packaged form for 1 hour. Okay. The relevant code for precast concrete in buildings is 1343. However, I'm saying that if you're working with the bridges, you have to follow IRC 112. If you're working with the railways, you have to work with the IRS code. That means you have to have this flexibility whenever you go to the industry. Now, what is prestressing? It is the application of an initial load on a structure to enable it counteract the stresses arising from subsequent loads during its service period. Now, once you put an initial load, there is a trouble. That means the member is always under load. Conventional members are under the self weight and superimposed dead load. But a pre-stressed member, along with that, it is also subjected to a compression. And hence, the creep is much more important in pre-stressed concrete as conventional to reinforced concrete. Now, if I look into India, pre-stressing was done during the British time. in Meerut, Karachi, the airport hangars were prestressed. Now, after the independence, the northeastern part of our country got disconnected completely because the railway lines were running from present-day Bangladesh. And the Assam Rail Link project was taken up in a war footing to get the northeast connected. The whole country was in a turmoil at that time. Please note, there was a refugee influx and a lot of problem at that time. And this was a mega project taken up in our country by the Indian Railways. Now, among the bridges, the Pamban Road Bridge is a classic example, and I will show you the photographs today, which is in connects the Rameswaram Island with mainland India. Now, the person behind this Assam Rail Link project was Colonel Singh. There is a classic report by him, a complete story of the Assam Rail Link project, which you can download it from the internet. And you will be able to appreciate that even 75 years back, the way it was written, absolutely brilliant. It's not just a theory, no, it's how it was implemented. And along with him, he was of course also supported by John Gammon, who had come to India to bring in the technology. Mr. V.N. Heggare, who was with Gammon India Limited, his journal, Evolution of Precast Segmental Technology, is also worth reading. Sitaram Joshi was actually a Gandhian in principle, in dress. He wanted to bring this precast technology. Please note, Atmanirbharata or being self-reliant is not a present-day buzzword. No, it was right after 1947. And if you look into this particular, the advertisement, that his company is designing this Koshi bridge in UP. Please note, the bridges in UP and Bihar are in extreme challenging conditions because of this rivers which flows heavily during the rains. T.N. Subbarao, who was the lead of the Gammon India Limited, was a pioneer of what Gammon is today. Please note, these companies have an illustrious history. Our present generation don't know. Now, ignorance is not a solution. That's why we have to stay aware that what civil engineering has done to our country. We cannot blame because of our ignorance that there's nothing in civil engineering. Okay, you have role models. Better let's live up to the expectation of what our forefathers had left to us. This particular bridge, the Mahatma Gandhi Setu in Patna, is a classic example of the prestressed technology. In present day, of course, it has been subjected to corrosion. Now, the superstructure had to be replaced, but that's a different issue. Coming to the Pamban Bridge, this was done by Gammon. And here, if you look, this navigational spans, which has to have a minimum clearance from the high tide level, these were done by prestressed box sections. The approaches were, of course, of a different type. And apart from the steel bridge in Pamban, this bridge also is a classic example of technology, and this remained the only marine bridge till the Bandra-Worli Sea Link came up. And now we also have the Atal Setu, which is an absolutely brilliant technological marvel. Mr. Raghavan had mentioned about Chandar Alimchandni. I did not mention on the first day because his work was primarily with bridges. Today I'm mentioning him. He was the lead of Stoops. He worked with pioneers in France, brought that technology to our country. And this project was mentioned by Mr. Raghavan, which is the aqueduct in a very dry area of Maharashtra, where this pre-stressing was done. The whole section was optimized based on the hydraulic pressure. And what a wonderful aesthetic design just for an aqueduct. He has been honored by FIP. Even Mr. Subbarao had also been honored. Mr. Mahesh Tandon, he was trained in US and he's having the Tandon consultancy, and they have done wonderful work throughout Delhi and in the other parts of the country. They have worked on the metro viaducts, okay, and pre-stressing has been extensively used in this type of designs. Now coming to the advantages. First, the foremost of pre-stressed concrete is under service conditions, they stay uncracked. Typically, even if we design for like a cracked section under characteristic load, since the characteristic load doesn't occur most of the time, the section stays uncracked. And that leads to all the corollary benefits. Increased durability, increased strength in terms of the shear, and it also provides higher moment of inertia. While deflection calculations yesterday, I had written in bracket, consider the section to be uncracked. Means what? If it cracks, deflection will be more. That means if you are considering the section to be, if you can keep the section to be uncracked, then your deflection will be reduced. On the contrary, you can have higher spans, and that's what it's the next slide. That okay, another important because of uncracked is very important, which is not relevant to this present course, but those who are from the water and effluent treatment, for them it is very relevant that for any liquid storage tank, especially the circular tanks, you can incorporate pre-stressing. That means you can even think of this option, that go for a circular section, go for pre-stressing. There are different ways of doing it. Filament winding technique is there, and get that technology from abroad. Okay. Now, in terms of performance under dynamic load, now here I have just written some buzzword called resilience. These days we are moving towards resilient design. Resilient means reduced damage so that the functionality can be resumed as fast as possible. That is possible because the sections stay uncracked. Okay, even in dynamic load we get some benefit, and fatigue load. The second is the high span to depth ratios, which Mr. Raghavan had already mentioned, that this is a beneficial for the long span, whether it is buildings and of course bridges. Some typical numbers have been given that for the span to depth ratio, if a non-pre-stressed is 28:1, for pre-stressed we can go 45:1. These numbers I picked up from a book by Professor Collins and Mitchell. For the same span, the depth can be reduced, which leads to reduction in self-weight. But please note, whenever the depth gets reduced, you may have a trouble in deflection. That's why pre-stressing is reducing deflection. But then if you're reducing the cross section, again, it will increase the deflection. That means finally deflection check has to be done. And it can give aesthetic sections, and there can be economical in terms of at least the material consumption. But what are the challenges? And these challenges I'm saying with respect to the Indian context, that we need skilled technology. It is not just like a reinforced concrete, mix something and that's it. Put some water and that's it. No. Today, when Professor Liberato was saying that the initial stretching is very important, it has to be done by certified foremen, period. Because these are high hazard, and we are talking of very large members, not a laboratory type of test. Use of high strength materials is costly. We are going for fiber reinforced concrete. There's a proprietary material called ductile. These are costly materials which are used in pre-stressed. Additional costs for the auxiliary equipments. Okay, what are the equipments? We'll be talking about it. And of course, need quality control and inspection. Concrete cannot have bug holes, because whenever you are trying to stretch against the concrete, if it is having honeycomb, then there is trouble. Now, the pre-stressing can be classified in different ways based on how are you trying to apply the pre-stressing. Earlier days, they used some screw jacks. These days, we always use hydraulic jacks. External or internal pre-stressing. External means, which is relatively rare, that the strands are outside the section. It can happen in a box girder, but concealed within the box. Or it can be even outside, which you can see typically for strengthening purposes. The classification which today I will be showing is the pre-tensioning versus post-tensioning, because there are subtle differences in terms of the losses. Linear or circular. Linear means the members are like a axial member, whereas circular means it's for domes, cylinders, pipes, okay, water tanks. These are circular. Full, limited, or partial prestressing. That means if you are designing a section to not to have tensile stress under the service loads, that is called full prestressing. Initial attempts were like that no tensile stress, then concrete is safe. But then it was found that if I'm designing for no tensile stress for the characteristic load, it is becoming uneconomical. And hence, people relaxed that condition. They said that we will not have crack. There can be some tensile stress, but no cracking. That is called limited prestressing. In the 1343 terminology, these are type 1, type 2, and type 3. In the other international codes, some different terminology is there. See, what I tell to my students is that you should keep your mind flexible. Even if you are working in Chennai, you may be working for an American firm for a Saudi Arabian project. Which code will you be following? You don't know. Hence, you have to be flexible enough to adapt to international codes. And I feel Professor Liberato's lectures are helping in that, to make you understand there is something beyond just 456 and 1343. Uniact, and what is partial prestressing? Now, this is a very generic word. Partial prestressing means you are allowing to crack under the characteristic load, with the understanding that the characteristic load is what is called rare. See, this terminology we don't have in our code. Rare, transient, persistent. These are terminologies which has been brought by the Eurocode to classify the loads further. Hopefully, when that characteristic load goes away, the cracks can close. This is one concept of partial prestressing. Other concept of partial prestressing is that I am producing a member where the ultimate moment capacity is by the strands as well as the non-prestressed steel. Because, and this is invariably done in bridges, because the characteristic load which comes for this 70-year track or wheeled vehicle is very rare. Those are the military emergency situation type of design. Hence, if we want to reduce the cost, if I want to reduce the trouble of prestressing, then I can make it partially prestressed, means I'm supplementing the capacity with the conventional reinforcement. Uniaxial, biaxial, and multi-axial prestressing. For linear members, it is only in one direction. But if I look into slabs, it can be in two directions. If I look into a dome, it can be in three directions. Now, in this presentation, I'm just focusing on this pre-tension versus post-tension, and only with reference to precast members. Now, these photographs I had taken when I went to visit a railway sleeper. Let's try to understand the procedure, because what is the purpose of a factory visit? Factory visit will not talk about equations, okay, but it will give you an insight that how theory is being implemented. And let me tell you, unless you can implement the technology, there's no point of just talking in a class. Okay, each of them are entrepreneurs. See, we typically don't realize who are the entrepreneurs in civil engineering. They are the entrepreneurs. Okay, one Mr. George had established this factory. Here you can see this is called a traveling stress bench, where the inside we have the mold where the strands are anchored, and this mold is placed within a self-equilibrating reaction frame. Now, this whole thing can move in rails, because different operations at different locations of the factory. First, this is the operation, that traveling stress bench, where the strands have been anchored. This is the dead end. On the other side, it is a live end. And this is the picture of the live end, where the jack, double acting jacks, is stretching out this thick plate against which these strands are anchored. That means once this plate moves out, the strands get elongated. And please note there are several, about 5 uh, sleepers in one bench. Accordingly, you have to do the calculations. And there are at least 2 ways of monitoring the load. One is there are pressure gauges by which it is telling how much load you are applying. And then you also measure the elongation to make sure that sometimes it can happen if the strands are not stretching properly, somewhere it has got stuck. Your load is going up, but your stretching is not there. That is dangerous. Okay. Hence, you have to have this double check that whether you are stretching it to the estimated elongation. Now we have the material properties. I already said in the chapter of material properties in the handbook that this itself is a area. And in this course, the next week will be material based. This week it is more structures based. Next week material based, and again towards the end we will come to structures. From the hopper, that means there is a mixer up there where we went, but I could not take photograph because it's very dusty. The concrete comes down through a hopper, and then once the concrete is poured, this whole stress bench is vibrated. How is it vibrated? There are certain motors attached to it. By that it is shaken. That means people will also use some needle vibrator, but this external vibrators give a better finish. Then this is through the rails, it is sent to the curing chamber. There is a protocol for curing. Once it is cured, they are brought out and then they are cut. Once they are cut, the individual the sleepers are separated. This is the way they are demolding it, and then they are stacked for further moist curing. From here, the Indian Railways will take this up. And in fact, there is the next photograph I will show, the Patil infrastructure. Let me show that photograph. This I had shown earlier also, that this is the flow chart for the production of this railway sleepers. I'm just quickly going through them today. Mold preparation, fixing of the insert, placing wires in position, stressing, batching after moisture analysis, pouring of concrete and compacting, removing the insert pin. These insert pins are of course specific for the sleepers. These are the requirements of the sleeper design, where you have the clips, where you finally have the clips to fix the rails. Steam curing as per the approved cycle, testing of the concrete cubes, demolding, writing batch number and date of casting, inspection and end painting. What is the purpose of end painting? That these are exposed. That means there they will be putting some asphalt so that the strands don't get corroded. Water curing for another 14 days, water cube test, inspection, stocking, dispatch. That means you have to have an idea that if you are venturing into layout, to develop a factory, what should be the setup? These days, you also design this setup. There's one Professor Koshi Verghese who can tell you how to lay out this to make it more economical. This was taken by Patil Rail Infrastructure. They have supplied these sleepers to Sri Lanka after it was devastated by the tsunami. Their whole Ilam area was again the railway lines had to be placed, and we in fact went there to see this particular project. That depends, I cannot say by a single number. I felt 16 hours a bit fast. When I went to this, they were doing 24 hours. That means it can vary from place to place. Okay, and maybe from what are you producing? See, steam curing typically the way they do a cycle is equivalent to 7 days. That means before you're cutting, you're trying to achieve the 7-day compressive strength. Now, if you are able to do it in 16 hours, perhaps that they are doing, even I was also surprised that they're cutting it in 16 hours. Okay. 16 hours means it's like 2 shifts, whereas 24 hours means 3 shifts. Okay, because these plants typically run 24 hours. Okay. And now, I'm not the right person to say which will be applicable where. Okay, this is an industry information. You can, it's a very good question. You can ask for the precast. Their Timage is of course not doing railway sleepers. Their production rate will not be as demanding as railway sleepers, and this production rates also fluctuate depending upon the demands. Like when we visited Patil Railway, they had to dispatch immediately some huge lot of sleepers to Sri Lanka, and they had requested us just to make, I mean, actually Indian Railways requested us, uh, IRCON, the construction wing of Indian Railways, that to check what Patil Railway is doing is as per the specifications or not. That was our job. But for us, it was a good learning to see how they are doing the things. But please ask this question to the teammate, that how much they're, at what time they're cutting if they're doing the pre-stressing. I'm pretty sure Holocaust labs may be having something else. Okay, some other band. Yeah, this is the Holocaust lab. This is the photograph from the teammate. This is also an assembly line process which I had shown earlier. This is the anchored end. Now this is the extruder. There are different types of fixture to have different types of voids, and finally you get this type of precast pretension products. And you have the catalogs to know the strength based on their span. Now, what are the advantages of pretensioning? That it is suitable for precast members which are produced in bulk. That's why today when Professor Liberato said that I will just restrict myself to pretension. Absence of large anchorage device. Okay, we need a factory type of situation, but big jacks, big anchorages are not necessary. So, on the contrary, the disadvantages are we have to have a pre-stressing bed with end abutments, okay, or a traveling stress bench. Stress bench is a shorter form or a smaller version of a pre-stressing bed. We of course need the mold shuttering, the jacks, small anchoring devices, and harping device. Now, harping device is not very common in our country because it's based on economics. That if you are going for a bridge girder, then you can profile the strands by lowering down at certain points. Those are called the harp points. Coming to the post-tension members. Now, this project I had the opportunity to see in Cochin, the fabrication of U-girders for bridges, and you can see the post-tensioning ducts. Once it is fabricated, then it is moved to this shade where the concreting is done. That means the concreting is being done under controlled environment. And in Cochin, it can rain anytime. That's why the concreting is being done under the shade. Now, once the concreting has been done and it has got some minimum strength, again it is taken out, because you cannot make factories throughout, and these are all temporary facilities. And here they are doing further curing. Now, once the curing is over, this is a floating barge. This operation was of course being done by Afghans. They're lifting them up, and what Professor Raghavan had said, that they use this high tide to place this on the piers. And this is a nice bridge. This is actually a set of 3 bridges. I personally felt it was very nicely done, very aesthetically done, okay, in this backwaters of Cochin. Coming to eye girders, this factory is in Chennai itself. And here, these are the girders for the metro viaducts. These are the molds where they are cast, the ducts are inside, and these are the anchorages which we need. And once the stretching is over, they will cover it up with mortar to check corrosion of the anchorages. What are the advantages of post-tensioning relative to pre-tensioning? That it is suitable for heavy members. Okay. Less waiting time period in a casting bed. that, see, in the post tensioning, typically you are taking advantage of the concrete itself to do the stretching. You don't need any pre-stressing bench. Okay. Now in pre-tension, since there is no physical anchorages at the end, we need something called transfer length. Today, Professor Liberato was talking about that. And if the transfer length encroaches in the critical shear section, then we have to check whether the shear capacity is adequate or not. Whereas in post tension, we do not talk about transfer length. Okay. And it is suitable for segmental construction. Now, I had one section on segmental construction, but since this course is not for bridges, I skipped that section. Okay. And it can be post tension, it can be applied for curved, horizontally curved members. Disadvantages that we need heavy duty jacks, we need the ducts and grouting. Now there will be a full lecture on grouting by Professor Pillai. That operation itself is very important along with the material. Devices for post tensioning, we need of course a casting bed, which is not, I mean, it doesn't need an end apartment, just a casting bed, molds, the ducts, anchoring devices, jacks, couplers if necessary, and grouting equipment. Now, the next important thing is losses in prestress. Now, this is an issue which has to be thought about in the design stage itself. The losses, this is more for the undergraduate students, that the losses can be broadly classified as immediate losses and time-dependent losses. Now, what are the immediate losses? Elastic shortening. This was raised today that in pre-tension members, whenever you cut the strands, the members shorten. And that reduction leads to a slight reduction of the pre-stressing force that you have recorded by the pressure gauge. That has to be accounted for somehow. For a post-tensioned member, if the duct is curved, then there is a frictional loss. Means if you are having one dead end, one live end, the load that you are recording in the live end will not be the same the load if you record in the dead end. Where is it vanishing? Because the strand is acting against this duct like a belt, okay, on a like a roller, and that frictional effect reduces the pre-stressing force over the length. That means in an actual design office, you do these calculations at certain intervals because your pre-stressing force is varying. You can also try to overcome this by trying to jack from the two sides simultaneously. When we took our students to the Katipara Junction flyover, they were doing post tensioning from both the ends simultaneously. Anchorage slip is a small loss which affects near the live end. That whenever you are trying to remove the jack, there is a certain movement of the anchoring wedge, which leads to this anchorage slip effect on the pre-stressing force. On the contrary, the time-dependent losses are much more difficult to estimate. Creep, we had already seen, and our Indian code 1343 as well as the bridge code IRC 112 have all expressions. I didn't want to load up with expressions in this course. Those who are interested, you can learn. Okay. Creep is a phenomenon. How we define creep? That it is the deformation, especially the contraction of the concrete in presence of the constant compression. What is shrinkage? Shrinkage is the reduction in actually volume, but it is the length which matters. The reduction in the length due to the loss of moisture. Of course, there are, as I said, that there are two types of shrinkage, which is called autogenous shrinkage and plastic shrinkage. Autogenous is just inherent, it is there even during the curing time because of the cement reaction. And the plastic shrinkage is once you stop curing, then the plastic shrinkage kicks in. And relaxation means it is the drop in the stress whenever you're trying to keep the strands fixed in the anchorages. Now, when we go for the structure slab visit, we will show you the relaxation chamber. I believe it is going to come in the next week. The short-term immediate losses are like physical phenomenon where we can write equations based on mechanics, whereas the long-term losses are material phenomena. And lots of work have been done on this. There was one faculty member from Italy, Professor Chiorino, who was monitoring the loss of pre-stress in a dome, which is constructed in the medieval time, but then retrofitted because the domes have hoop. Yesterday, Professor Liberato was talking about this, that there is a hoop stress in this and Pantheon. Similarly, in any dome structure, there will be a hoop stress. And to counteract this hoop stress, they have done some retrofitting, but then they're monitoring it. Okay. And please note, there's data of 35 years. In our PhD program, after 2-3 years, we feel tired. But then you have to have the patience in your life, okay, to contribute. Coming to the analysis, I will be very briefly going to the analysis so that at least those who are not familiar with prestressed concrete, you can do some basic calculations. That for an axial member, okay, what are the axial members? It can be like a ties of a truss. Okay. Once you release the prestress, then the stress it's like a uniform uniaxial compression coming on the concrete. What is the stress? It is the force divided by the area of the concrete, which can be approximated to the total cross sectional area. Precisely, you should remove the area of the strand, but for today's tutorial purpose, you say that area of the concrete is equal to the area of the section. Next, once it is subjected to a service level load, then there is some tension. Now, please note in my notations, it is just the opposite of what Professor Liberato has said. In my case, the compression is negative and the tension is considered to be positive. Now, I have written plus minus that in case if a member comes under compression, a prestressed member, then actually its strength comes down. It is not good to prestress a member under compression. But then you may ask, why do we prestress piles? Because the piles in marine environment are subjected to a lateral load constantly. During earthquake, they can be subjected to uplift forces. And hence, for those situations, you are doing the prestressing. You are paying the price by slightly increasing the section, but prestressing is beneficial for the service conditions under constant lateral loads. Now here, how do you calculate the stress? That the first component is due to the prestressing force. Please note it is now in effective, means after the losses. To that, you are either adding or subtracting the effect due to the external force. Here, I have written the term transformed section. What is transformed section? It is the equivalent, what he said today, that as if it's an equivalent concrete section. But again, for today's tutorial or even for quick calculations, you can say that transformed section is close to the gross section. That's it. Coming to the members under flexure. Why do we do the analysis? Now, we have to be clear that when to do the analysis. First, the permissible prestress based on allowable stresses are transferred. This was also mentioned today that prestressing, the stressing operation itself, whether it is post tension or whether it is pre tension, the stressing operation itself is a testing time of the concrete that you have cast. And hence, the stresses have to be limited to allowable values based on the instantaneous concrete strength. Next, you check the stresses under service conditions. The allowable stresses should be under the stresses should be under the allowable values permitted for service conditions. And then we talk about, in case if there is an overloading, what will be the moment that will nullify the effect of compression? That is called moment at decompression. Or if the moment further increases, what is the moment at cracking? And finally, you see the ultimate strength, which Professor Liberato had mentioned. Ultimate strength means it's the once in a lifetime event. Okay, but that's where we cannot compromise, that at least we should design that structure for that rare or extremely rare condition, because our civil engineering failures can be devastating. I tell my students that don't lose faith in civil engineering. If you are in electronics manufacturer, if it doesn't work, yes, it may create trouble. Your cell phones may not work, it creates irritation, but you throw it off and buy a new one, or you tell your parents to buy a new one for you. Of course, if there are troubles in aircrafts, then it's what can happen. However, in civil engineering, it can be a disaster. We should actually all learn from the aviation what happened. That if you are neglecting any step, it can create a disaster. Okay. And sometimes our students think that, oh, anyway, we have safety factors that will take care of my wrong calculations. No. Safety factors take care of the inherent variability in the material. It is not there to take care of your mistakes. And the entire load versus deformation behavior, that is we need if I want to study what is called ductility. That is important whenever there is an overloading. If I am using pre-stressing for seismic purpose, then this becomes important. Today I am not going through all this. I will be just restricting myself to calculate the stresses. In order to calculate the stresses under service condition, at transfer or under service conditions, we use the main assumptions. The plane sections remain plane, but today Professor Liberato nicely mentioned that when you cannot consider a linear strain diagram, even if plane sections remain plane. And when does plane sections remain does not plane? Pondalraj can explain that. Okay, for whenever the members are deep, and he studied deep girders. That here what we are considering is that the members are straight and distribution of the normal strains is linear across the depth. See, some of these assumptions we just take it for some knowledge in our undergraduate, but as you grow up, you should understand that where they cannot be applied, because in your real life you will be having exciting sections, not just the standard beam. Okay. And for the straight members with prismatic sections, there's a vertical plane of symmetry. That's what we are assuming. We are not talking of curved members here. Okay, or members which can be subjected to what is called that lateral torsional buckling. Those are it can come. We are not talking about here. Now, since it remains uncracked, at least at transfer and hopefully in service, we can use the principle of superposition. What means is that the stress due to one effect, I'm adding the stress due to another effect and getting the total stress. But you cannot use the principle of superpositions once I'm going into the nonlinear region, especially for the deformations. Please be careful. The increase in stress in the pre-stressing steel due to the pre-stressing steel also bends under service load, but we will neglect it. The analysis at transfer and service loads are similar. I'm just explaining for the service loads. And if you're talking of any analysis for the transient situation, that doing lifting, that means you can follow the similar lines. The analysis can be done in 3 approaches. The most important is a stress-based approach. It is necessary because we have to ensure that the stresses are limited. The second approach, which uses the force concept, this is used in the design. That means whenever I'm trying to know how much pre-stress I have to place, I need to know the force. And that is a force-based concept which is used for the design. The third concept, the load balancing concept, is typically used for deflections. Yesterday I told you a formula for deflection of the planks or the beams. But if the same members are pre-stressed, then you have to account for the camber due to pre-stressing and the deflection due to self-weight and superimposed dead load and come up with the final deflection. That is the load balancing approach. Now here we are just restricting ourselves to the stress concept, and the purpose of doing this is to check that the stresses at least at transfer and at service and somewhere in between, they are within the allowable values. Here I'm just giving an example based on a member with a strand which is at a constant eccentricity throughout the length, just for demonstration. That here, as if it is subjected to a uniformly distributed load, and the strand is there to counteract the effect of this load. And now if I try to understand this, I would prefer that you draw this type of sketches. My advisor would not give marks if you do not draw these sketches. What are these sketches? These are the individual components. You don't have to memorize formulas. You have to just understand the mechanics. That first, that this is a condition which can be there at service or at transfer. At transfer, M is equal to only the self weight. At service, M is the total service load moment. At transfer, P is the loss right after immediate loss, whereas at service, P is the value after the total losses. That this P first has say a uniform component, which is P by A, and the negative sign is to mean compression. Then, since the strand is eccentric at the midspan, then I have a varying stress, where for a positive eccentricity means it is for positive bending. There I put more compression at the bottom. And then with the external load, it is just the reverse stress diagram. And all three gives us this stress profile across the depth. What we are interested is the stress at the bottom and the stress at the top. At transfer, my stress at the bottom is highly compressive. It should not be crossing the allowable value. The stress at the top may become tensile. I have to be careful, it should not crack. On the contrary, under service condition, the stress at the top should not be very high that it gives a lot of creep effects. And the stress at the bottom depends upon whether you are designing it as type 1, type 2, or type 3 member. If it is type 1, no tensile stress. Type 2 means tensile stress but less than the cracking value. And type 3 means it's a limited. And this is my expression. As I said, that once I understand this, my expression looks much simpler than the way Professor Liberato had presented. Okay. And you can choose the way you write this. He had used the section moduli. I am saying that the stress is as per the fundamental flexure formula that we learned in our second year engineering. It's the moment times the distance from the neutral axis divided by the moment of inertia. You can also use the section moduli concept. If a tendon is curved, which is in a post-tension member, one can be a bit more picky by saying that I will just take only the horizontal component, but that is not necessary. Okay, with this, I am ending this coverage of prestressed concrete, just to make you aware that this technology is very much in tune with precast members, and hence at least I should know the basics of analysis. Whatever I covered, in fact, those who are undergraduate students, it will also help you in your GATE exam. That in GATE, this is the syllabus for prestressed concrete. They will not ask you any design questions or any other shear or anything else. Okay.